Hi everybody. So we're going to be starting our next project here, but before we do that, I would be quite remiss if I didn't at least share with all of you my heartfelt thanks and gratitude for all of the kind comments and so many emails, comments, poems, things that I received from my last video when I announced that Bella had died, our dog. I am truly touched by that, and any of you out there who think that there's not any good, kind, caring people left in this world, you only need to go back to that last video and read through all the comments, for you. They certainly meant a lot to me, and I hope that any of you out there who have any doubt in your mind about the goodness of this world still, I hope you go through and look through a few of them. Thank you all. I appreciate it. So, just so you all know, we do have one more little friend living with us. It's my daughter's cat. Her name is Mango. She's a rescue cat with her little wonky ear. And she's been with us for maybe about a year or two. And she's an older cat, but she doesn't really leave the upstairs very often. And she very rarely comes down here. So if we want to see her, I would have to take the camera up there and get a little shot of her. But maybe one of these days we'll do that. Anyway, thank you all again. I appreciate it. Now let's get on with our next video, which, I don't know, maybe my hair up here will be falling out after I go through this project, because I think it's going to be a little bit challenging. We'll see. All right, on with the video. So we announced this at the last video that I did, where I kind of showed you some of the up-and-coming projects that I have in the queue. And it was really between this one and the Lafayette amplifier, because I can't believe how many of you commented on that Lafayette. I'm a big fan of Lafayette also, simply because my cousin worked for Lafayette Radio Electronics when he was in tech school and just right out of tech school, and got kind of his start in electronics, formal electronics repair with them. And a lot of the Lafayette products, he lived in the Cleveland, Ohio area, and a lot of the Lafayette products really were kind of circulating around that Cleveland area and became available. So we had access to a lot of their products, both from his working there and from just all the pawn shops and antique stores and flea markets and things like that there was quite an abundance of it. So I have quite a history with it as a kid, and I had some of these things, and so they're kind of near and dear to my heart. So I kind of understand why so many of you were so interested in that, because I know a lot of you shared that you had the same or similar experience. So we're going to do that one next. But this one here, I just couldn't resist. I want to get on it. I really am burned out on tuners. I've done quite a few of them, and I would kind of suggest that if you're interested in such things, go back through a lot of my videos. We've done quite a few high-end audio tuners in the from the high-end audio field in the past videos. But I have never worked on one of these. This is a Kenwood model KT917. You can see over there, maybe not from the glare. And this thing is pretty complex. It's not like anything I've worked on before, and I have never serviced one of these, and I've never really seen one in real life. If you look at this, it is massive. It is an FM only tuner. It doesn't even have AM. At least the Sansui TUX one that we did, it was AM and FM, and it was a little bit taller than this, but certainly not bigger. So here's our ruler. We're looking at 16 inches deep, which is roughly 16, and 40 centimeters. And if we go this direction, 18 inches wide, or 46 centimeters wide roughly, and about 16 centimeters or 6.5 inches tall. So this is a big receiver, or tuner I should say. It's not a receiver. There's no amplifier. It's just an FM tuner. That's it. So you might say to yourself, how on earth do they need such a large case for this thing? Well, we're going to find that out. And I did print out the service manual, and I kind of printed the schematic portion on large paper. So this should be really fun to work on. When you read on the Tuner Information Center online, which is an online resource for tuners, you can read a lot of comments where people say this is a very particularly difficult receiver to align and to work on. There are a lot of circuits that are used in this that are kind of unique, or that typically you won't see them all in one unit. They're kind of features that you know, usually are featured in high-end receivers, but not all of them together like this. Basically, you name it, this thing has it, and it definitely is supposed to be a very high-performing. Not only that, it should rival the audio quality of just about anything out there, from what I understand or from what I'm seeing. And unfortunately, there aren't a whole lot of FM stereo broadcast stations out there that broadcast in the fidelity that some of the older stations of the 1970s and 1980s were broadcasting in. So I don't know if we'll be able to receive you know, a station that can really show what this thing can do, but we can simulate that with our Sencor SG80 and kind of making our own internal little radio station here. And we'll do that in the end if we can get this thing working. Now, this thing was found by my friend who collects audio gear like this. He trades in it and so forth. And the person who had this purchased it at an estate sale. It was kind of cruddy. He was a non-technical person. He tried to clean it up as best he could to kind of increase the value, obviously, but he was not a technical person. He did assure my friend that he did not tweak or adjust any of the settings in here. That would be devastating because this is a very complex receiver to align, from what I understand. Again, we'll see. So I think we have a pretty good chance of getting this thing going. Now, to my understanding, it does not work. It might tune one station in, but that's about it. And right off the bat, I see a problem. I just noticed this because I have only had this for a little while, but look at the dial scale. It starts at 75 megahertz and only goes up to about 100 megahertz. So this is not a United States FM band tuner. This is for the Japanese market, I believe, is what that is. And the other thing we're going to have to see, being that that's the way it is this thing wired for 100 volts? I've not plugged it in or anything, but we're definitely going to have to look at a few things, and I hope he didn't do damage. If it is a 100 volt unit, I hope he didn't do any damage by plugging this thing into 120 volts, if it's a 100 volt unit. So we have a few things to look at, and then we'll go from there. Okay, so as I start to look at this more carefully, as I said, this is for the Japan market, and we didn't catch that. I didn't see it. I mean, I took it when it came in here, I opened it up, everything looked really good, and I never looked at the dial scale. How about that? But the way you can tell this is for the Japanese marketplace is the Japanese FM broadcast range is from 70, I think it's like 75 to 95, or no, 76 to 95 megahertz, I believe is the official range. And you can see it starts at 76 megahertz and goes up to 95. For those of you who are not aware, the CCIR, or the standard FM broadcast band that we use here in the United States and throughout other parts of the world, starts at 88 megahertz and goes up to 108 megahertz. So technically there is some overlap, but not very much. You see how wide the dial scale is here? If I go all the way up here, This is the very beginning of the broadcast band in the United States. So from here to here is all that we can tune in here in the States. So from here on down, it is not FM broadcast. It's a different frequency allocation. So this is not going to really work over here in the States, but it is probably very highly collectible over in the Japanese market, because vintage high-end audio over there is still very, very collectible and highly sought after. So I do know that it's probably worth a lot over there, and that's probably where it will end up. But I have one more thing that makes this a little bit more perplexing. Let's take a look. If you take a look at this unit's serial tag and so forth, the power rating is rated at AC 120 volts. Now over in Japan, the standard mains voltage over there is 100 volts. So it's very strange. I can't quite figure this out. This has the frequency range of the Japanese market, but it has the voltage range of the United States market. And the only thing I could figure is that possibly this receiver, or this tuner, was sold in the Japanese market, but sold for export for some reason with that frequency range, and somebody must have been, military or something, had this over there and purchased it and brought it over here when they came back to the States. That's the only thing I can figure. Again, I've never seen anything like this before, so this is a lot of these export ones that are import or export or whatever, that can be multi parts of the world. They will have a little dial or a little jumper in the back where you can change the mains voltage between 100, 120, and 230 volts. But this one does not have that I can see, and we will have to look at the schematics and look inside the unit to see if actually there is a way to change it to 100 volts, because really if this runs at 120, even if you wanted to sell this in the Japanese marketplace, correct me if I'm wrong out there, guys, but I think we would have to use a step-down transformer to get this voltage into the correct range. So I'm hoping that there is a tap on the transformer that we could move this, and that it could be switched to 100 volts in case somebody over in the Japanese market would want to purchase this and import it over to there. So anyway, we're going to kind of change this video a little bit. We're going to still check it out. We're going to make sure it works. And we still have the means to generate those frequencies and get a modulated output. And we can at least test to see if everything works. And if it does, then, well, we'll button it back up and it'll be on its way. So, not exactly the video I was intending to make for all of you, but hey, you never know when you get into this used equipment, do you? Okay, now obviously my schematics are not going to perfectly match the schematics that we have, or going to match the circuit that we have here because of the different frequency, and the main difference is going to be in the front end, in the RF section. Once it converts into IF, I would assume that the entire receiver is exactly the same. There's no difference between the two models. But again, we don't know what they do to change the band of the two different models. It could be something as simple as a jumper or changing a couple components, or it could mean replacing the entire tuning gang and everything, which would be impossible today with how rare these units are. Now, looking at the schematic of the power transformer, you can see that this only has 2 wires. There is no multi-tap for this particular one. Now, if this is the transformer that is inside our unit, we cannot change it to 100 volts. Now, it says right here, interestingly enough, I'm going to bring you in as close as I can. Right here it says 120 volts. But if you look at the plug, it says AC 100 volts. So I don't really know what that means. Maybe this will function because it uses regulated power supplies for everything. Maybe what this means is that if you put the lower voltage in this, even though these outputs would be low, once it goes through the voltage regulators, they clamp it down far enough that you would still get the proper regulated voltages out. Maybe that's what they mean there. We have our variac and so forth, so we can actually put 100 volts in here and see what our power supplies look like. We'll check all that. So again, very, very interesting, isn't it? Well, that was a quick solving of the mystery. There's your transformer. And it says 100 volts. And so this is truly a Japanese model. The tag says 120 volts. I don't know if that means that you can put up to 120 into the transformer and not without harming it. That I don't know. But it definitely says 100 volts on this transformer, but it says 120 volts on the tag, whatever that means. So we will have to look into that a little more. And we can always dial in 100 volts. It won't hurt anything. We have the means to do that here. Look at that power supply. You talk about capacitors. So this is a recapper's wet dream for sure. It's not something that I would want to do. I think when the seller said that he could only pick up a couple of stations, I think he could only pick up a couple of stations because, well, there's only a small range in the United States that we can tune into with this one. So maybe this thing is perfectly okay. We're going to find out. All right, as you can see, I have an antenna connected. I have my little bench amplifier connected to the output. We are going to use our little electronic circuit breaker and variac module, and you can see on the right analog meter it is set to 100 volts AC. And let's turn this on and find out if we get any sound. And I have my signal generator set to 83 megahertz. We're doing 24.8 microvolts out. So let's turn it on. Let me see if I get any. Okay, it lights up. And I have the volume up pretty high. I don't hear any sound at all. There is no sound. So let's see if we're having difficulty with the, well, let's tune. So I'm right on going across 83 megahertz, and there is no sign of any tuning activity whatsoever. So for whatever reason, everything's dead. So it could be a power supply issue. So the first thing we want to do is look at our power supplies. Okay, we're going to have problems the whole way down the line here. Here is for the export version of this receiver, or this tuner. You can see the PC board outline, and you can see how it has this little notch cut out of it, and you can see the incoming fuses from the power transformer go into the end of the board, and then it goes down to the rest of the power supply. When you look at what we have here, the fuses are on their own separate board down here, and then the power supply board is rectangular with no notch cut out of it. And it even looks like so a lot of the rest of it is similar, but the board layout looks to be somewhat different. If we go this way, yeah, it's pretty close. So we should be able to still measure what we need to measure. So let me get acclimated here, and we'll do some tests. Okay. So what I'm seeing is this board, other than having that little piece detached from it, it does line up with the board that we have. So you can see up here we have plus and minus 14 volts. We have 15 volts, minus 18 volts, and plus 18 volts. So those are all of our power supplies, and then a 22.5 volt. So we have, on the 22.5, we have 23.1, that's pretty close. On our 18 volt, we have 18.9. And there's our minus 18 volt, which is minus 18.9. Our 15 volt is 15.278. Minus 15 right here is minus 15. Minus 14 is minus 14.3. Our minus, what's this one? Minus 15 is minus 14.3. So it's a little low, not bad. Here is our plus 14 at the top. And we have no plus 14. It's minus 8.0. So we're missing our 14 volt supply, the plus 14, so we'll need to see what's causing that. We have a failed component, and that's probably why we're not getting any output. So let's look into that. Okay, looking at this very tiny and very hard to see schematic, here's what's going on with our 14 volts. So you come out of D11 and you have your 20.5 volts unregulated, and it goes through this current pass transistor. It is regulated by this little servo circuit, this little error amp, and it's a just a little op amp. I don't know what it is. What is it, 4558 or something like that? I'll have to look it up. And we can see that we should have 18 volts at the base of Q7, which is a small signal transistor, which is paired up in Darlington pair with this Q1, which is a pretty good sized TO220 transistor up on a heatsink. And so what we need to do is, let's make sure we have our 20 volts going in there. And let's make sure we have our 18 volts coming out of pin 1 of our error amp. And then see what we're getting out here if we have our 14 volts. So we're going to look at those areas right now. Okay, I'm most likely going to be in the way of the meter when I measure this because it's just hard to get at the right angle. Sorry, I had my microphone off, and it probably was off for the last clip too, but sorry about that. So here is that op amp right here, and I don't know if I can get the lighting good enough without getting all kinds of glare in there, but we'll try, huh? Well, there's a little bit of glare, but it's about as good as we can get it. How's that? Not bad. All right, take the glasses off because Tony can't see. And get up here into pin 1. And we can see pin 1 has the 18 volts. So we have 18 volts coming out of IC1, which is going into the base of Q7, which I would say is down here. Yep, there it is. And on the collector of Q7, I should have my 20.5 volts, or somewhere around there. And that would be right there, and I do. But at the output, which would be going into the base of the pass transistor, I have negative 0.2 volts. So we may have a bad transistor. And looking at this transistor, it's all bubbled and crusty at the top as if it burned up, and I see a burn mark on the board around here. So maybe our transistor is bad. So let's power down and let's just do some static testing of that transistor. Now it's going to be difficult to test in circuit because it's in a Darlington pair with that other transistor. So really we're going to need to remove it to totally test it. Do you see that up there? It's right here at the top. Do you see how it's kind of bubbled up? And if you look at this one here, for example, that's how it should look on the top. Now that just could be the way it was machined. I don't know, but something tells me there's something wrong with that transistor. We're going to have to take it out. Well, I would say that this transistor has seen better days. Take a look. It is, yeah, it's cooked. Let's put it in a little tester here and see just how it reads. I bet you it's open. No component or whatever. It is a resistor. It is an 86.8 ohm resistor. Bad transistor. So we're going to have to check all the circuitry around it, and we're also going to have to make sure that something else in the receiver, in the tuner section, and anywhere else in the unit is not shorting our 14-volt supply. And that's pretty easy to do because we can actually disconnect each of the wires going to the different parts of the receiver to eliminate shorts and things. But before we do that, we're going to get the actual power supply repaired. Okay, this was a 2SC 945 according to the service manual here, and it can be replaced with a KSC 945, so we have one of those. But before we do that, we are going to remove the pass transistor, which is a, what is that one? That is Q1, and Q1 is a 2SD330. You can see that one up here with the little bracket off. We can see that, and we just need to take these two screws out and desolder these 3 pins. And good grief, I've had a couple of comments. You never show anything. You don't show us how to unsolder something, you know. Okay, I will show it to you for the 16 trillionth time. You've seen this on here. But, not to disappoint, here it is. With my left hand, even though I'm right-handed. There's one pin. 2 pins as I'm reaching around the camera. And there's 3 pins. That is how you desolder the transistor. Now, I also got a comment complaining that I don't show you how to replace said transistor. So we will do that as well. I will take this little screw out of here if I can. I might need a shorter screwdriver. It would be better if I had, but I'm too lazy to get it out. So we'll take that screw off. And we'll take that screw off. It's amazing how grumpy people get over the simplest little things. I wish my life was so simple that something tiny like that would be a huge issue and get me all upset. They must be living good. I don't know. So here's the transistor here. We're not even going to take it out of the heat sink. I think we can fit it into our little tester. Maybe. Yeah, I think so. And let's see what we get. Diode. Well, that's not good. So let's take it out of the heat sink, just in case the leads weren't getting down into the tester far enough. And test it a second time to make sure that we just weren't getting a good bite on it. Let's see here, take that out. Okay, let's pop this back in. Now we know we got good contact. Diode. So that transistor is bad. So we have 2 bad transistors. So we need the equivalent of a 2SD 330. Okay, so according to ST Thompson Industries, on their cross-reference sheet, it says a 2SD 330 should cross over to a TIP 31A. So that should be a pretty easy one to find. I think I have one of those. So let's see what we have. Okay, I dug through my stash, and this is the closest I could find, and I think this will be a really good match. The main difference on this is the same as an ECG 291, I believe. And it should be, with the exception of the gain being higher, it should be a really good match for this 2SD 330. We're also going to check some other things before we go. We're going to check the Zener diode that's in there, because that could be bad. We're going to check the resistors, and we're going to check some of the surrounding capacitors and just make sure we don't have any problems. Alright, so we have this little Zener diode out, which goes right here, this D3, and it looks pretty toasty. But of course it was right next to that burned up transistor. And if we use our Zener diode tester, let's see. This is an XZ051, which is a 5.1 volt Zener. And it's 4.9, so it's a little bit low. But at 5 milliamps, it's right about dead on 5.1. 10 milliamps, yeah, so it's good. So I would say this one is good. But of course, now that I took it out, I'll probably just throw another one in there because I have a whole pack. I have a whole bunch of them. So we'll replace that, but that's definitely not a problem. I believe that IC1 is good, and IC1 is an 4558, so that's just a plain old 4558 op amp, and we can replace that if we have to, but I don't think it's bad. We're also going to check R5, because it's right next to that burned up transistor, and it's this 560 ohm resistor. You can see that there. Let's check that real quick. A 560 ohm resistor, and that's not looking good there, unless there's a capacitor or something across there. But that's reading 700 ohms, and it says in the schematic that it should be a 560 ohm resistor. And looking in here, we can see, yep, it is green, blue, brown. So that would be 560. So 560 ohm, and it's reading 700. So that definitely needs to be replaced. If we look a little more carefully at it, you can see it's charred. And then we want to check these couple of capacitors in here. Turn this glare off of here for you. Let's see what we get here. C7, that's one of the ones I really want to see here as I sit behind here. That one's good. I have a feeling these aren't going to be too bad. Let's see. That's very good for that small of a value. Good. Good. So no problem with our caps here. Let's see. Can I see? Yep. These are all good. I'll go through and check the rest of them later, but I think for now, I mean, all the voltages except that one were good. And I don't think any of these caps are going to read bad. And we'll see where we are, and we'll just do a quick static test of the 14 volts to ground to see what a resistance reading is. That isn't, you know, an end-all be-all test, but at least if we go from ground to that, it's reading about 70 some ohms, and it's going up, so there's a capacitor that you're reading across. But yeah, so if we say 75 ohms and we have 14 volts, would be 186 milliamps times 14, so that's going to be about 2.6 watts. That is a good bit of power for that little transistor. But of course, this is a 40-watt transistor and a pretty large heat sink, so that may not be too far out of line for that. We'll see. But at least it's not a dead short. We know that. We'll power it up and see how it works, but I'm not worried about trying it out now. Okay, so see if we can do this around the camera for your viewing pleasure. I'm going to start at the bottom. There it is. Let's see if we did a decent job. Yes, right up there. I think that looks good. We'll clean that up a little bit later with some alcohol. Now let's take our KSC 945 and place it in right like so. I'll take the center leg and I'll just tack that in. Let's see here. See if I can tack that in there a little bit. Kind of hard to reach. Like so. And we'll straighten it out here. We'll cut our leads to the proper length. And we should be good. As I bang the camera, my grandson is up there having fun. I don't know what he's doing. I think he's playing with my son. Must be playing trains up there, building tracks. We love our trains. Okay, let's see here. Okay, and then we will just touch up this middle. Nice. Okay. Now, let's see here. You can see the amount of crud that came off of that board under that KSC 945. It really scorched that board, so it burned up pretty good. So let's just clean this off. We'll clean this off. Actually, not that much flux there. Looks good. All right, let me grab another 5.1 volt Zener and I'll be right back. Okay, we have a nice new 5.1 volt Zener, and I have it in the tester just to kind of show you the difference. And you can see we're at 5.4. It's a little bit high, but you can see as I change the current, the voltage, the Zener voltage hardly changes at all. See, between 2 and 15 milliamps. And if you recall, on the other one, it drifted quite a bit. Now, Zener diodes will do that with changes in current, but this one was pretty substantial. So, looking at this one, we'll do the same test. And you can see at 15 milliamps it's 5.2, and at 2 milliamps it's 4.9. So you can see how much the Zener voltage changes with current. And again, that's normal, but it shouldn't be as much as that one is. So that one is getting tired. It needs to be replaced. So I'm glad we're replacing it. So let's get this into position. I don't think there's any high current there because this is just kind of a little voltage source for that op amp, so I don't think there's going to be any current on it really. Oh, I think we're getting a storm coming in. We just got in not too long ago, so I'm glad it's coming now instead of half an hour ago. And yeah, I should have clipped those leads first, but who cares? I won't tell if you won't tell. There we go. And of course, let's not forget our 560 ohm resistor, and I'm just going to put one of these metal film jobs in there. Should be a little more durable. That might be what was already in there, I don't know. Okay. Let's see. Where is our offending resistor? There it is. Yeah, that's kind of discolored too. So, I don't know. Definitely, whatever it was, I think that little KSC or 2SC945 shorted out, and I think that's what caused all the problems. And you know, part of me wonders, maybe the person that tried to plug this in and test it, because he said it worked for a little bit, you know, maybe they plugged it into 120 volts and the excess current is what caused this thing to fail. Because linear power supplies are like that. When you have a linear power supply, whatever voltage above whatever you want there is, you have to, it basically gets dropped across the circuit. So for instance, if you have a 5-volt power supply, let's say, or a 5-volt output, and you feed it with a 10-volt source, that means 5 volts has to be dropped across the circuit and converted into heat. So of course, the more voltage you're dropping across that linear regulator, the more heat it has to produce to limit that voltage and keep it constant. So that's not a good thing. And so if you plug this into 125 volts, and this is a 100 volt transformer, what's going to happen is you're putting 25% higher voltage in there than you want. And of course, that means you have 25% more voltage to drop across your regulator circuit, which is going to increase the amount of current and the amount of, well, not the current, but the amount of wattage that is going to be dropped across there and be dissipated by all those transistors. So that might be what it was. I don't know. Again, I'm kind of confused why this is a 100 volt transformer, but the outside tag says this is a 125 volt machine. But I don't know. All right, I think we're ready to try this out now. Let me get the meter hooked up. Okay, I hope we have the whole thing in shot. I have the power back on. We're still at 100 volts mains. And let's see what we get. And we have about 15 volts, so it's a little bit high. It's about a volt high. That could be because of that pass transistor that's in there. And that just scared the crap out of me. But that is the radio coming on. So let's turn on our signal generator and listen to that. Music to my ears. Okay, that was my wife announcing that there is a huge hailstorm coming our way, and my poor daughter is driving through it. So the last big hailstorm I had was 1985, and it was golf ball size hail, and that's when a giant tornado came through our town, and it trashed all of our cars. We had to have them all repaired from the hail damage. But hopefully that won't happen this time. But it's absolutely pitch black out there, and it's still early. It's, you know, it's only about Well, it's about 8 o'clock p.m., but normally we still have some daylight at this time of year. So anyway, let's get back to work. And if I look, the tuning is absolutely perfect. And let's see what kind of sensitivity. That's 2 microvolts, but definitely this thing's working fine. So all that was wrong was that power supply. And the rest of our voltages are still looking good. Let's see here. Yeah, everything's really good. But our plus 14 is a little, well, no, it's down to, no, it's still around 15. So it is a little bit high, but I don't think that'll hurt anything. It should work okay. And part of that could be because of the pass transistor having a little higher gain. And I can feel it warming up a little bit. It is slightly warmer than the negative power supply, but no more so than I would ever expect, so that doesn't seem too bad. And the transistor, the resistor, the Zener diode, everything is cool. So I'm chalking that up to our new component is a little bit different, has a little higher gain, and probably that's affecting it a little bit. In addition, our Zener diode, our 5.1 was reading about 5.4, and so you have that 0.3 volt difference. So your reference is a little different, but all in all, I think it'll be okay. I think this thing's ready to test out now. So as you can see, it generally works, but none of the meters work, and I'll show you why that is in a little bit. What we did was we kind of made our own little makeshift radio station. So I'm using the SG80 as the multiplex generator. I'm feeding it with an external signal from my sound system over here with the Scarlett 212. Or 2i2, whatever it's called, you know, my sound interface. And then that's feeding into the external modulation input of the 8657 so that I can get the frequencies that I need for this goofy dial scale. Now the other problem we're running into is, I'm not sure in Japan, I'll have to look it up, but I have the 75 microsecond pre-emphasis set up on this, and it sounds a little bit tinny. And I have a feeling, but it sounds too muffled when I have it turned off. And I have a feeling that in Japan they use 50 microsecond pre-emphasis, but I could be totally wrong on that. I'll put a note on there because I will look that up and specify. The stereo doesn't kick in perfectly. I think we're going to have to look into that a little bit. But the reason none of the meters work is because they're all disconnected. Somebody went in there, whoever was playing around with this thing must have taken the faceplate off and then never rewired it. So taking a look down here, you can see how the wires are just dangling. I found these two hanging in here. I found the other two for this meter over here disconnected, and these ones for the signal strength meter are nowhere to be found, so they're probably tucked under there shorting something out, who knows. So I'm going to have to pull this back out to get to it, and then we're going to have to connect these meters back up. Again, the person that got this apparently found it at a yard sale, I verified, and it was dirty, so he tried to clean it up so that he could get more money out of it, I guess, but he wasn't a technical person, so that always scares me. But he assured my friend that this was not, he didn't try to tweak anything, so be that as it may. So let's connect these meters. Okay, you can see in the glary camera that the meters are now working. And if we tune off of station, you can see the tuning meter and the signal strength meter. And we get stereo. And I now have another problem. I have the amplifier that we were listening to connected to the fixed outputs. My oscilloscope, to be able to monitor it, I have connected to the variable output. And if I move you over to the oscilloscope, I think you'll very clearly see the problem that we're having. And if I move the volume up and down, you can see that one channel moves, the other one really doesn't until you get almost to the end and it drops right out. So we have some kind of a problem with the pot there. We'll have to take care of that. It may need cleaned, to be cleaned, or it may actually have, you know, a fault in it. We'll see. But in the meantime, I'm mainly interested right now in seeing what kind of, let's see here, I have to turn the modulation up. There we go. And then we can turn this down quite a bit, and you can see it does not work. Not at all. So, but we'll take care of that. And let's go to left plus right, left minus right, right and left. And you can see how perfect the separation is on that. And let's go back into XY mode. I had a person comment about, I think he really was misunderstanding what I was saying about left and right. So this is a normal stereo signal. And if we go to a mono signal, it looks the same. That's how it should look. If I go to left plus right, it should look the same, because mono is left plus right. If I go to left, and you can see it is sloping 45 degrees off axis, see that? And I kept saying that, and he kept freaking out and saying, when you go to left minus right, it's 180 degrees, not 90, you're stupid. Listen to what I'm saying. Once again, they are 180 degrees out of phase. If we go back to this, if I go to left minus right, you can see left and right are 180 degrees out of phase, so they technically cancel out. But if I go to the XY mode, what you're seeing is now our line is sloping, instead of straight up and down, is sloping 45 degrees to the left. If I go to left plus right, it slopes 45 degrees to the right. In other words, the angle difference between this and this is 90 degrees of the physical XY Lissajous pattern. That's what I am talking about. If you are the gentleman who was commenting and I was trying to explain this, this is what I'm talking about, okay? Not this, okay? Not that. See the difference? The reason that I like using XY mode on this is because when we go to right only, we should be able to see, if we line this up, in a perfect world, if there's no bleed over between left and right channel, you'll get a perfect vertical line like that. And if I go to left only, you should get a perfect horizontal line. If you were getting some bleed over, in other words, if there was a little bit of audio on the other channel, this would not be exactly flat with this horizontal line. It would actually be tilted slightly one direction or the other based on how much signal you're putting. And this only works with your signal generator, with a multiplex signal generator. You can't really use it with stereo audio like music, because the waveforms are all over the place and they're in and out of phase with one another and all kinds of things. But with your signal generator, this is a very, very good way to see if your multiplex circuit is properly aligned. Does that make sense? So again, left only, right only, left minus right, left plus right, and then stereo and mono will all look the same. So left plus right, stereo and mono will give you the same sloping 45 degrees that direction of a line. I hope that clears that up. So we can see that other than having to clean the pot, and you can see when I turn that pot, see what happens? And see how the line separates and you get like an oval? That's what happens when one channel is different than the other. You will not get that perfectly straight line. So if I could go back over to audio and we feed some music in there, you can hear it. So you see, you don't get a straight line. You're seeing the difference between the two channels being played out. So anyway, that's just some interesting things that you can do with your two-channel oscilloscope. Now what you're going to find out is if you try to do this on a digital oscilloscope, especially some of the lower end ones that don't have a really good sample rate, they'll kind of look pixelated. You won't see those nice crisp lines on there that you're seeing right now. What you'll see is it'll kind of look pixelated and fuzzy looking, but you can still see it. It'll still work. You can do it. And the better digital scopes don't have that problem. They have enough sample rate and everything to be able to, I'm probably not using the correct terminology, to be able to view that list-as-you pattern perfectly. Because it's an analog signal you're looking at there. And it's a pretty complicated, complex one. So once again, everything's working perfectly, we can see. So let's just go over some of this circuitry because really there's nothing to adjust. So we'll clean that pot. We'll talk a little bit about how this tuner is very unique compared to the standard FM tuners that you would see out there from this era. And then we'll wrap it up. All right, now that we've heard this thing work and kind of saw a few things on the scope and so forth, let's talk about some of the features of this thing and what makes it so unique. First of all, when it comes to the FM de-emphasis, I did look it up, and yes, in Japan, FM de-emphasis is 50 microseconds, not 75 microseconds like it is here in the United States. And unfortunately, on the export versions of this tuner, it's switchable. So there will be either a switchable for 75 and 50, or 75 and 50, or 75 and 25, which would be a model that was made to work with Dolby FM, which was a very short-lived broadcast mode where they could broadcast a Dolby encoded FM stereo that was supposed to be a lot better fidelity and clearer sounding and so forth. It didn't catch on, and it wasn't around for very long. But unfortunately, if you have the domestic Japanese version of this, which is what this one is, I believe, there is no switch on the board here to be able to switch it between, there would be actually a slide switch on there, where to be able to switch it between the 75 and 50 microseconds. So this will never sound proper here in the United States. If I tune in a perfect broadcast FM stereo station that's, you know, high fidelity and so forth, it's very strong signal, it still will not sound right because the FM de-emphasis is not correct for this country. All right. That said, the front end on this thing is pretty nice. As you can see, there's a lot of adjustments, and there are no less than, well, let's count them on the schematic. You have your switching unit, which is what switches between antenna 1 and antenna 2. And then you go through your tuning gang, and it is a 9-gang tuner. And you can see that we have a couple different stages of RF amplifier in there, which is pretty advanced front end, and you can see all that in here. And we can, you can see as you can adjust all the stages, and you have a coil and a capacitor at each stage. And of course, you use the coils for the lower end of the dial scale and the capacitors for the higher end of the dial scale to bring it in, and each one you balance. These are all perfect, so we don't have to touch them. You've seen me do that enough times on other receivers. That's not anything unique. Although this one with this 9-gang tuner is pretty unique because of that. When we get to the IF section, and that's where we convert the RF station into that continuous 10.7 megahertz intermediate frequency. That's how a super heterodyne receiver works, and I go over that on a lot of my previous videos. And you can see on this one, this is a little bit unique. There are a few things. The first thing is this thing employs, and I'm not really, I really have not studied how it works, but they have a thing called a DDL, or a distortion detected loop circuit. And what it essentially does is it monitors the distortion of your IF band, and then it acts to, it can shift your local oscillator so that if things are a little bit off kilter, it'll shift it back on to center. So it's kind of like a self-adjusting local oscillator, I guess, if I'm saying that correctly. Once you get your local oscillator and you produce that 10.7 megahertz, then it goes through a series of filters, and there's actually 4 stages of filtration here. And instead of using just a regular ceramic filter, so the first filter it goes through is a ceramic filter, and I think that's this little component right here. And you can see it on the schematic right here. And then it goes through your first transformer, and then through a little amplifier stage or buffer stage. It's like a common gate amplifier. It goes through another transformer, and then you start going through these little op amps. And each op amp, and you can see them right here, 1, 2, 3, and 4. Each one of those goes through this special filter. And this is not just a normal ceramic filter. These are called SAW filters, or surface acoustic wave filters. Now, SAW filters are used usually in the higher end tuners, but you don't see them very often in the, in your normal tuner that you would buy off the street from that day. Is usually these high end ones that had them, and they have a lot sharper cutoff than a ceramic filter. They're a lot more accurate with their center frequency. They don't drift as much, and they have a lot wider, better bandwidth than any ceramic filter you could use. So they're superior in every way to a standard ceramic filter. And there are 4 of those suckers in here. And these are not all the same part number either. You could see they have different part numbers on them. There's 2 different types, 2 of each. And these things were custom designed to the specification that Kenwood provided to Murata Corporation. Murata made these. So you will not be able to buy these if they ever go bad. Even if you could find a SAW filter, which those aren't even real common these days, you would never get this one unless you took one out of an old tuner of one of these. So it goes through 4 stages of that, and then it goes through what's called dual conversion. So they take that 10.7 megahertz signal and they down convert it even further to a 1.96 megahertz IF. And once they do that, it'll go through another filter, and essentially it'll be detected from there. And that's where it really gets interesting. Number one, FM broadcast tuners don't typically have dual conversion. Now, we've seen that on some of the shortwave communications receivers that I've done some videos on that had dual conversion, and there's some that even have triple and quad conversion. But usually on these you won't see, I mean, they'll just have a single 10.7 megahertz IF, not a second one like this. So that's unique. But then once it comes out of there, when you detect the audio, that's the detector section, is where you take the audio off of that IF. That's really unique on this one. And what they're using on that is a circuit called a pulse count detector. It's almost like a digital circuit that it's a type of quadrature detector, and anybody who's into RF knows what a quadrature detector is. It's different from your standard Foster-Seeley or ratio detector. But beyond that, it actually has some digital circuitry that essentially how do I explain it? It'll turn the your FM audio or your FM signal, you know, that downscanned 1.6 megahertz signal, it'll downscan that into and convert it into a uniform like pulse of energy, and then that detector will respond to the number of those energy packets or pulses. Okay, and so this pulse count thing can make a very linear operation over a wide variety of deviation range. So like when deviation in FM is how far off center frequency your modulation will deviate. And one of the problems with a standard ratio detector is that the further the deviation, the more the signal can distort. Whereas when you convert it into this digital pulse count circuit, theoretically, it shouldn't allow that to happen. And you shouldn't be able to pass any noise through the circuit by that. Because it's turning it into digital information. So again, I'm not familiar with how the pulse count circuit works, and that is this board here on the back. And it comes out of this, it goes through that. So this whole board is your detector section, and there's really no alignment of it. It's all digital. So that's the other thing is, you know, your old ratio detector circuits, you had that can that you adjusted, you know, the top and the bottom coil. And remember how you would set one to center the frequency, you know, so it's at 0 when there's no deviation. And then the other one you would adjust for minimum distortion. This does away with all of that. It does it digitally, at least to what I understand. So pretty unique. From there, it goes into a very complex multiplex circuit, and that's what this is. This is what takes your FM mono and breaks it down into your stereo right and left. And the way it does it is, again, very advanced. So it uses what's called a sample and hold processing. So it'll sample the 38 kilohertz and the subcarrier, and then it will sample it at that peak of each cycle, and then it stores it like in a capacitive, like in a capacitor, in between the samples, and then it'll decode from there. So, and it even, I believe this thing even has a digital circuit for canceling out the pilot signal. So really, this is a tuner that was right at the edge of where we were going to go from a totally analog tuning system to your synthesized tuners, you know. So this doesn't really have a synthesized tuner. It does not have your Vericap diodes. It doesn't do that. And I showed you, I think we looked at that. I think we did the realistic STA 2200. That one had synthesized tuning. We looked at the F26 and F28 Pioneers. Those had a type of synthesized tuning in them. We looked at some of the more modern tuners out there that had totally synthesized, that were completely done on an integrated circuit. But you can see this is still discrete components, and even though I wouldn't call this a digital tuner, it employs some digital circuitry in with the analog to make it almost, but not quite, a digital tuner. So it's really unique how they did this, and you can tell they were just stretching the technology that they had at the time, because they didn't quite have what they needed to have a true digital synthesized tuner, or at least it would have been too expensive to do that, or too complex back then, and they did it with analog circuitry. So this is really cool. That's why I like this tuner, and I was looking forward to going through all that. But the more I look at some of the procedures, I think some of these things are going to be different, because this is a domestic Japanese unit rather than an export for the United States unit. So the schematics and alignment procedure I have is for the export model, and this is the domestic Japanese model. So I really don't want to mess with it, especially since it's working so well, as we saw. But again, even if we did align this, if it is aligned perfectly and everything, the de-emphasis is wrong for this country. The dial scale is wrong for this country. So this tuner really isn't very useful for here. So probably what this is going to do is it's going to find a nice home over in Japan. I'm sure somebody will really want to have this one over there, because it will work a treat over there. But anyhow, that's kind of a little rundown on how this thing works. And not very well explained, because this is my first one I've ever worked on, and I've only kind of scratched the surface into how this thing functions. But it's very interesting. So the SAW filters, the dual conversion, the 9-gang front end, the pulse count detector circuit, and the DDL for the distortion detected loop at the beginning. All of those things, very unique, very cool, and I don't know, I think it'd be pretty good. Should be a good tuner. Unfortunately, we'll never know unless we could be in Japan with the proper radio station to tune into. And just for fun, let's do a little left-right test signal. Here we go.
Front, center, side, left, side, right, front, center, side, left, side, right.
So you see how that works? So pretty interesting stuff, huh? I'm going to turn this down so I don't burn a hole in my scope screen. All right. Okay, before I wrap up the video, I'm going to show you over here on my SG80 that this is capable of putting a 75 microsecond pre-emphasis on your audio, which would simulate what your radio transmitter station is going to do with the audio before you broadcast it. And I have it turned on right now. And again, as I said, it's set up for the United States for 75 microseconds. And we're going to tune it in with our 50 microsecond pre-emphasis tuner. And I'll play you a little piece. And what I'm going to do is I'll keep you focused on this, and I will put the microphone next to the speaker so that you can hear what it sounds like when I switch between the wrong pre-emphasis and no pre-emphasis. And you'll see that no matter which way I switch it, even with this microphone, you'll tell that the audio is just not quite right, especially with the treble. It'll sound kind of sibilant when we have this turned on, and it'll sound kind of muffled when there's no pre-emphasis turned on. So let's start up this song. It's called TikTok, and it's nothing special, but it does have some cymbals and some bells and a few different sounds that might show this a little bit. So here we go. Did you hear the difference? You could kind of hear that. And what you'll find out is as the music gets more intense, with the 75 microseconds turned on, it'll start to sound, the highs just won't sound right. And the bass just won't sound right. It's just, the whole thing is not perfectly balanced either way. And if we'd had a 50 microsecond pre-emphasis on this, it would sound perfect. That being said, this tuner is very, very, very quiet, and it does a very good job of tuning in even a very weak station. And it can go all the way down to about 2 microvolts, which is pretty good, and keep the station sounding really good at that low level. You'll have some background static, of course, but it does a really nice job. The other thing is this signal meter, just like on the F28 that we did and on the TUX1, you can see how it has these numbers, and it's actually measured in dBF, or dB with reference to 1 femtowatt. A femtowatt is a thousandth of a milliwatt, or microwatt, I'm sorry. It's very, very, very small. And they even give you a little chart of converting to your microvolts. And you can see how they do that. So, because we use the microvolt setting a lot of times on our meters or on our test equipment, and it has to be properly terminated at 75 or 300 ohms in order for these numbers to be correct. And of course, I don't have my my matching jig put in there because, again, my impedance matching box is only good between 88 and 108 megahertz, and it's really the most accurate around 98 megahertz, and this tuner will not go up to 98 megahertz. So I'll never be able to get a perfect reading. I would have to always put an error calculation in there. So that's another reason I would not attempt to do the alignment on this, although again, I believe the alignment is good on this. Nobody seems to have messed with it. So that was a lot of prattling on about this tuner, and it certainly, we did do some troubleshooting, we did do some demonstrations of some things and talked about some different features of this, but it really wasn't the video I expected that it was going to be. It never is it? But anyway, this is long enough. I'm going to end this video, and we're going to move on. We're probably going to do that Lafayette because I had so many comments about that. So we'll put that up on the bench and check it out next. So until then, I wish you all peace, joy, happiness, and good health in your lives. And I wish you all the best, and we'll see you all again real soon. And take care, everybody. Bye-bye.